welcome back to Unit 7, Day 3, Proving Parallelograms. We've looked at our 5 methods a few times, our 5 theorems for how to prove we have parallelograms. Both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, or both pairs of opposite angles are congruent, or diagonals both bisect each other, or one pair of opposite sides is both congruent and parallel. And we've looked at some examples of determining whether or not we have parallelograms, of determining what we need to show we have a parallelogram, and now we're going to look at a quadrilateral on the coordinate plane and determine whether or not we can prove it's a parallelogram. Okay, so determine whether ABCD is a parallelogram. The first thing I want to do is I want to graph it, right? Because I need to know where those 4 corners are so I can see it. So A is at negative 2, 3. Negative 2, 1, 2, 3. This is A. B is at 3, 2. 3, 2. This is B. C is at 2, negative 1. 2, negative 1. That's C. And D is at negative 3, 0. D is at negative 3, 0. So here is my parallelogram. Okay. And remember, we have 5 methods of showing that we do indeed have a parallelogram. Okay. I'm going to start at the bottom and work backwards. Number 5, if one pair of opposite sides is both congruent and parallel. Okay. So if we look at that, one pair of opposite sides is both congruent and parallel. I can pick one pair of opposite sides. Let's say I look at AD and I look at BC. Okay? Determining if they're congruent, I can use the distance formula using these 2 coordinates and then using these 2 coordinates, or I can think of it like a little right triangle where I'm looking for the hypotenuse, right? So the distance from A to D, I'm trying to find that. If I want to know how long this is a hypotenuse, so inside my square root I would add, and I need to go up. My 2 legs are 1, 2, 3, and 1. So 3 squared and 1 squared. That's going to be the square root of 3 squared is 9, plus 1 squared is 1. So that's going to be the square root of 10, which is, I'm not 100% sure what that is, so let me get my calculator and do the square root of 10 is 3.16228. I didn't do any rounding, but since I'm not giving my actual answer, I'd like to know what the whole number is. Okay? And then when I want to find this length right here, BC, that's going to be the square root of, and then, so this is a hypotenuse that I'd be trying to find if I made this into a little right triangle. So I'm adding, and I've got 1, 2, 3, and 1 again. 3 squared and 1 squared. So notice since it's starting with those same 2 numbers, it's still going to be 9 plus 1, which is still going to be the square root of 10, which I don't have to put that in my calculator again. I already know that's going to be equal. So I know that these 2 pieces have the same length, but are they parallel? Remember, if they're parallel, then they are going to have the same slope. So I need to know what is the slope of segment AD. I can tell it's positive because it's going uphill. I have to go up 1, 2, 3, and over 1. So up 3, over 1, it has a slope of 3. The other one, I have to go up 3, 1, 2, 3, and over 1. So my slope of BC is also up 1, 2, 3, over 1. So that is also a slope of 3. So they do have the same slope. That means they are parallel. So using the very last theorem, I just started with number 5, I was able to show that this is indeed a parallelogram. Okay? Remember I told you in the last video, though, there might be an easier way to do it. What I might think is easy might not be what you think is easy. Okay? So let's talk about how you could use the others to figure this one out. Okay? So if I look at number 4, if the diagonals bisect each other, then the quadrilateral is a parallelogram. Okay? So to find out if the diagonals bisect each other, that's actually going to be a pretty involved process, because first you'd have to draw them in and find their intersection, and then you'd have to do the distance formula, or this Pythagorean theorem situation here. You'd have to do it 1, 2, 3, 4 times. Okay, so probably that one is not going to be your easiest bet. I probably would try to stay away from our 4th theorem. Okay, opposite angles, it's really going to be quite the effort to determine what these angles are, because you'd have to figure out how to make this angle. What would I need to do so that I could try to figure out how to make it a right triangle? So I could use some inverse trig to find those angles. That's going to be, again, way more work than we want to do. Okay? My second theorem, working backwards, both pairs of opposite sides are congruent. Well, we're halfway there, right? We already showed that these two sides were congruent. So then I would just have to do what I did here for AD and BC with my Pythagorean theorem. I would do that for AB and DC so that I could show that these were congruent and these are congruent. But then my number one is probably actually the easiest. I should have started top to bottom, because if both pairs of opposite sides are parallel, so if both pairs of opposite sides have the same slope, well, this was easy to do, right? We did this real quick. We said, oh, go up 1, 2, 3 over 1. Go up 1, 2, 3 over 1. That side's parallel. Let's check from A to B. I have to go down 1 and over 1, 2, 3, 4, 5. So that's a slope of -1/5 for A to B. Let's check out D to C. I have to go down 1 over 1, 2, 3, 4, 5. So that's also a negative slope of -1/5. Okay, so I can tell just by counting my slope, my rise over my run, that these are the same. And I wouldn't have really had to do this, right? If I would have started with number 1, it was real easy to go up 3 over 1, up 3 over 1, parallel. Down 1 over 5, down 1 over 5, parallel. Both pairs of opposite sides, parallel, done, moving on. Okay? All right, thank you so much for watching. Hopefully you have information now and feel confident in being able to prove that a quadrilateral that you've been given is indeed a parallelogram. All right, thank you so much for watching.